So today we're doing problem number 22 for our video project, and we're just going to find the equivalent capacitance of this circuit with these capacitors. So first we're going to find the equivalent capacitance of these two capacitors in parallel. So we rewrote it over here, and this equivalent capacitor is what we're looking for. So for capacitors in parallel, the capacitance is additive, so it will be equal to 50 millifarads plus 20 millifarads, which is 70 millifarads. Next, we're going to find the equivalent capacitance of the capacitors in series. There's two sets in series here. These two are in series together, and these two are in series together. And we know they're in series because the left side of one is connected to the right side of the other. So, for capacitors in series, they're inverse additive, which means that the capacitance of the equivalent capacitor is equal to 1 over the capacitance of the capacitors that we're adding. So, for the top series, we have 1 over CS equals 1 over 40 millifarads plus 1 over 24 millifarads, which is equal to 1 over 15 millifarads. So the first equivalent capacitance we're looking for is 15 millifarads. And I'll just write that up here. The second is 1 over 30 millifarads plus 1 over 70 millifarads, which is 1 over 21 millifarads. So that capacitance of this equivalent capacitor is 21 millifarads. And we'll just write that here.
Okay, so now that we've simplified our circuit down a little bit, the next thing we have to do is combine these two that are in parallel. And so capacitors in parallel are additive, so we add 15 microfarads and 21 microfarads to get 36 microfarads, which creates two capacitors in series. And so capacitors in series are anti-additive, so 1 over the equivalent capacitance will be 1 over the 36 microfarads we calculated, plus 1 over 18 microfarads. And that will yield 3 over 36 microfarads, which is equivalent to 12. And so because of that, we know that if this one capacitor is equal to 12 microfarads, that the equivalent capacitance of this entire circuit is 12 microfarads, which is our final answer.
For the last parts, B and C for this question, it just asks us to locate two capacitors that have the same charge and two capacitors that have the same voltage change. And so these two capacitors right here, because they're in series, will have the same charge. Capacitors in series always have the same charge. And then these two capacitors right here will always have the same voltage drop because capacitors in parallel have the same voltage.